can appreciate that. Okay, we're getting, again, as I say, I'm used to having that 8th week that's easier. For some reason, they seem to have shifted I'm going to write down some stuff, short term, long term, market power. Let's see what else. What other topics do I want to think about? Price taker. Okay. So let me just make sure that's going. Let's see if that. Okay. Okay, I think that's. There we go. Okay, so those are the things there. Now what I want you to do, I'm going to ask you to come up one by one, and we're going to go over each of these 4 model areas, and I'm going to want you to get up, and we're going to go one-on-one and explain what each of the. I'm going to give you an individual topic to talk about. I'm going to want you to come up and explain to me. In the best you can to see if you understand this, and if you don't, well, this will be a one-on-one tutoring. You'll get one-on-one tutoring, and it's a small class, so you don't have to worry. It's not like there's 100 people out there, and you can kind of pretend like there's just it's just you and your professor that are having a private tutoring session. And so let me think. Who would I? Ask to come up first. If you can come up first, so what I want you to do is come up. Have you can bring a chair. But I want you to come up, and I'm going to have you write on the board. We're going to go over and say, okay. And what I want you to do is talk about natural monopoly. And tell me what natural monopoly is. Give me a demand function, and then we'll go through the process and see how you calculate it all and come up with something. So if you can please come up, and I know he's the least shy, so I'm asking him to come up first. So
record.
Well, that's it.
You will show up in the video. Okay.
Perfect competition.
Well, I really want them to. I really want everyone to see this. It's not that to be able to see this. So if you can please come up, because the thing about it, at some point you're going to have to get up and make presentations, and so you might as well get used to it. So this is a small class. And you have nothing to be embarrassed about. I think you're going to have no problem here. So, I know. So please come up. Okay. So what we're going to do is we're going to talk about, and first he's going to talk about natural monopoly. That's going to be your topic. So I want you to talk about that, and just go up on the board. Okay, and the first thing is to tell me what is the natural monopoly. Describe to me what the natural monopoly is, and in terms of first in terms of short term and long term.
First, I will demonstrate the natural monopoly has. The characteristics of monopoly, it means only the single firm, and the firm has the market power, so the demand curve is downward sloping. The very special point is the natural monopoly has a very high entry cost.
Which means what?
Which means
what kind of model are we talking about here?
What kind of model?
Is this a short term or long term? Is this a short term model or long term?
Long term.
It's not long term.
Long term.
It's not long term, because remember is that what we're talking about. If we're talking about entry, In the long, if we're talking about entry, we're thinking what happens when the firm, whether a firm can enter or not. So we're talking about fixed costs. The fixed cost is a short term.
In the long term, all cost is variable.
That's right. All cost is variable in the long term. So in the short term, that's why what we're here, we're interested in the short. This is a short-term model. So keep that in mind. That we're talking about natural monopoly. We're talking about, write that down, a short-term model. It's a short-term model. So in other words, what we're thinking, we're trying to think about, we're modeling these markets in different aspects to show how you get an outcome. And so we're looking at these, and this is to show you, because I think one of the things that perhaps you're struggling with, and maybe other students are struggling with, what's separating these? What's making these different? So what we're going to do is we're going to say, well, it's a short-term model. So a short-term model, we're interested in fixed costs. That's what makes it a short-term model. We're interested in fixed costs. And why are we interested in fixed costs? That's now what I want you to talk about, is why are we interested in fixed costs? What is it about fixed costs see if we get that high. I think that's fine. Yeah, let's see. That's getting I think that's basically getting in there. Not all of it, but that's somewhere like that. Okay, I can back this up a little bit. Let me try to. Is that okay? Let's see. I don't know how that's going to come out, but let's see if that, because the lighting is actually not good for. But we'll see how that goes. But at least we can talk and see. So it's a short-term model. Okay, large fixed cost. Okay. Large fixed cost. And what else? What is it about? And now, what about our marginal cost, our variable cost? What kind of variable costs do we have relative to the fixed cost?
The variable cost is very low, and we can just don't care about the variable cost.
It's relatively low. It's relatively low. So you have it's a large fixed cost. It could be something with a lot of infrastructure. So it's relatively low. It doesn't have to be zero, but if we say zero, that's okay. And that's why we can model that. Okay, that we have a relatively low relative to the fixed cost, which also means there's a large entry cost. There's a large entry cost. That's the thing. It's a large entry cost. So we have a short-term model, large fixed cost, large entry cost. So now write up some model. Yeah.
Like
okay. So what is a demand? Write the demand function. Right. Okay. You've got this demand function.
The demand function.
You're getting ahead. Let's not.
This
Let's. You mean marginal revenue?
Yeah.
Let's get to that in a minute. Okay. That's correct. Right. He's got 100 minus QX. Why? Because when the price is 0, Q is 100. When the price is 100, Q is 0. So that's a very simple, and that's why I've had these are very simple models. But the thing that you want to say, well, okay, what is this? This is a demand function. Why is it? Now explain why this is a demand function. What does it tell us? What does it talk about? What makes it a demand function?
It tells us the market power, because the company can control the relation between the price and quantities.
Very good. It's the relationship. That's correct, but let's do that in. It's a demand function because it talks about the relationship between price and quantity. That's what makes it a demand function. Demand function tells us how price and quantity are related. That's what a demand function is. And what Johan says is that the firm has market power because a firm with market power can choose can manipulate quantity and price. That's what market power is. Okay. Okay, now, let's see, market power. So is the firm, is the monopolist a price taker? Could it be a price taker in any market?
Could you? What does it mean? Price taker in
Right.
any market?
Yes. Could it be a price taker in any market?
In competitive competition, all companies price taker.
What are we talking about here? Is this the input market or the output market?
It is a output market.
Correct. Very good. So we're not talking about this market. That would be, let's say.
That is a supply curve.
Right.
Margin cost.
Okay. So we're not talking about the input market. And so if we're assuming a relatively low marginal cost, then how important is the input market in this analysis?
Yeah, well, in this situation, the input price is a supply curve, which equals the marginal cost.
Right.
And the company.
That's a very important point, and each one of you are going to come up and repeat that. Your marginal cost is your supply curve. Very, very. Yeah. Now you could, we could have this kind of marginal cost curve, okay, but we could. The supply curve is the marginal cost curve, and each one of you are going to get up and you're going to understand this. If you don't understand it now, by the time you sit back down, you'll understand it. Okay. So don't worry about that. But what's interesting here, and Elon has this upward sloping marginal cost curve, but for this analysis, this is actually showing that this is a significant marginal cost. Okay. So we were actually not interested. We wouldn't use this in this model, but in some of your other models, you will. So we'll see this a little later in some of the models that you'll be talking about, but not necessarily here. So we can just erase that and now put give me a marginal cost curve. Write down a function for a marginal cost curve.
Marginal cost curve? You mean this function?
Yeah. No, you don't want that function because this is a kind of upward sloping.
Yeah.
It's an upward sloping. You
so
want
the marginal cost. It is relatively low, so the marginal cost is 0.
Okay, right. Well, why don't you write out an equation that is a relationship between the cost and quantity.
Okay.
So marginal cost curve. That put the relationship between price and quantity. And this is important. Watch this. How would we put? No, don't worry. Yeah, that's.
Price and quantity. The quantity didn't change, so the quantity does not matter. Just another.
And how do you show that it doesn't matter?
It doesn't matter. It is. So we don't show the quantity here.
You can. I want you to show the quantity.
So 0 multiply. Is that?
That's not 0. Because you have for all quantity of output. If you have a marginal cost of 0, then for all quantity of output it's 0. So write an equation that shows that. Not just marginal cost equals 0, write it out. Do you see what I'm asking? And here's what I want you to think about, is I want you to see, underline, not just to say that not just to write down marginal cost equals 0, that's okay. That's okay, but what I want you to see is the underlying, there's an equation that underlies it. Can you try to think about an equation that would describe?
If the quantity is 2.
Like this. But I'm going to draw this line. See that? Let me draw. That is my marginal cost line. See that? What does that tell us? That for all quantities, it's 0. So write down an equation, a cost function that shows that. Some cost. Let me put C. C equals the cost. Cost equals.
Cost equals QX.
Okay. Some constant. Let's use another letter.
Lambda.
Well, let's just say A and QX, and what's the, there's two ways that you could have A, there's actually two ways to do this, and I want you to see both of them, because it's going to be, I want you to keep this in mind for other models. So keep this in mind for other models, okay? So this is, what value could you have for A?
This is the marginal cost function.
Yeah.
I,
Now for this one, it might be appropriate for just 0.
zero.
Oh, 0.
I want to put 0.
Okay, let's say it's a positive number though. Let's make it some small positive number. Because we could say 0, but we could also have some relatively low number. Let's say if it's positive, and you still have the model. In the structure of this model, let's have some A greater than 0. Okay, so let's put an A greater than 0. So how would you make, now you're going to have something like that. Let's say you have a cost function that looks like that. It's not 0, because say marginal cost, I can write that, but let's say that A, but that's not really telling me what the functional form is, what the real functional form is, okay? So now what I want you to do is write me an equation for the cost, because the marginal cost comes from the cost function, okay? It comes from the cost function, so we really need to have a cost function. And we want a cost function that does not vary with quantity of output. A is greater than 0, how do I do that? I think that if you have 1, if you have 1, that let's see, that would work. Now your marginal cost, because whatever function you want to have a marginal cost that was, yeah, that works. That works. So that's it. That's some constant. That's some constant. That's some constant cost. Now derive. Tell me what the marginal cost is from that cost function.
The marginal cost.
In other words, why is it flat? Why is the marginal cost function flat? What's the derivative of that?
The derivative is A.
Correct. The derivative is A. Now, if you're not familiar, some of you are not, okay, that's good. Let's just do that. What's the derivative of the cost function with respect as we change the output level? So we change the output level, how does the cost change? So that is A equals C equals A QX. So show the derivative.
So the derivative is the marginal derivative is delta.
That's fine, that's fine.
So if this is 1,
Yes.
then 1 multiply A. If this is 2,
And yes, and then QX times QX
yeah,
times, do the full thing, do all of it so they can
times
see.
QX. Is it right?
No. QX1 minus QX1 minus.
QX1. Ah,
Yes.
ah.
Do it all, write it all out so they can see.
Y
1 minus,
1.
exactly, 1 minus 1. And what's 1 minus, what's QX to the 1 minus 1 power? That's QX to the,
0.
and so what's that?
1.
1. That's why. So when we end up, we get A. So that's why we have a cost function. That's not magic. It has to come from somewhere. So what we're doing here is I want you to get clear in your mind what the cost function is. The underlying cost function. That is the underlying cost function. That's the cost. Some cost A. It could be 0. It could be a positive number. But whatever it is, instead, when we write down marginal cost, we have to think that that's what this is. That's what's going on. That's what's going on. And when you take the derivative of qx, the derivative of qx is 1 times qx to the 1 minus 1 equals qx to the 0, which is equal to 1. So anything raised to the 0 power is 1. So remember that. So even if you don't understand calculus yet, just keep this in mind. Just keep these very simple rules in mind, and you can see that we're talking about what changes, how the marginal cost is how the cost changes with the change of 1 unit of qx. It's the change of the cost with the change of qx. So with 1 unit of qx, the change is just a. It just changes with a. The qx, it's because the derivative, 1 minus 1 is qx to the 0, that's 1. So it's a constant. If a is 0, then our marginal cost is 0. That's where it comes from. So, and the reason why I want you to understand that is so you need to understand that that's in all of these models. All these models have these kinds of things. You need to think about what that function is. In this case, it's some c equals a times qx, and that a is small. It's a small a, okay? And we can just call it 0, that's fine. That's fine, we can do that. So, now that you know that, and you're going to see this over and over again, because we're going to get up, and each one of you is going to get up, and we're going to have this conversation in different ways for the different models. And now what I want you to do, calculate the optimal action of the firm.
Optimal action.
Yes, what should the firm do, because the firm, what we're saying is the firm knows that.
So output at marginal cost equals marginal revenue. This
Correct.
is for all firms. This is the only.
So make that calculation.
So okay. So we need the marginal revenue. So I will draw this.
Well, you don't want to draw it until you get your revenue. You have to get your revenue function first.
Okay.
Get a marginal revenue until you calculate your revenue.
So revenue equals the price multiply quantity.
Correct. Okay.
Equals this is the price and the quantity.
Correct. Very good. Just hold it. You're doing fine. Let's just stop. Let's stop. Okay. He's doing great. We're doing great here. So we're make sure we got this right. He's doing revenue is price times quantity. That's what revenue is. What I sell a good for, and what the quantity is. And remember, in a monopoly, we can control these. The monopolist can control both of these. So that's the revenue. This is price. He's taking the price. That's the price times the quantity. Okay.
Okay. So this equals the. This is the square.
Yes.
So this is a kind of slope like this.
Correct.
So the maximum revenue is when the
To
derivative
some level,
is
right?
0.
So he's going to be able to. So it's 100. No, it's 100. 100Q. You forgot a term. You left out a term. 100Q. 100Q minus Q squared. Okay. So that is the revenue. That is your revenue. So that's our revenue curve. That's a revenue curve. And as Yuan said, it's some kind of it's a second order.
Yeah.
It's a second order function. So it's going to have something like that. So it has some maximum. So we're going to have some point where we maximize our revenue. And so if we have, and the reason why it's this, if we had a marginal cost, then it would be another term, and which would be related to Q. So, but we don't have that. Our marginal cost is 0. So we have this form. So now we have revenue. So now we need to calculate the marginal revenue. So how do we calculate the marginal revenue?
Marginal revenue.
How do you calculate the marginal revenue?
I don't.
You certainly do need
Just
to.
get the
No,
derivative.
of course, that's it.
Just
The marginal revenue is the derivative. That's the point.
The derivative revenue equals the...
He needs to calculate the derivative, because the derivative tells us how the revenue changes with the quantity. Because we want to find out what output maximizes revenue. Okay, great.
This is this. So when the derivative is 0, this is the maximum condition.
Correct.
So the Q equals 50.
Correct. So we do that. That is, and I'll go over this carefully so to make sure that you understand. Okay, we have here's the we have the revenue equals 100 Q minus Q squared. So the derivative is 2 times Q 2 minus 1. That's the derivative of the first term, plus Q, 1, that's Q to the 1, so that's 1 times 100 times Q to the 1 minus 1.
Minus 2. First,
Okay? Do you see that? Now, even if you don't know calculus, you can see that. That's just a rule. It's just a formula. It's just an automatic. It's something automatic. You just say, okay. Then and if you don't know calculus, well, you're learning. Okay, so now you set that equal to 0, and why? Why do we set that equal to 0? Explain that. You got some. It looks like that.
Because at this point, the marginal change is
The marginal change.
a line.
Yes.
So the slope is 0.
The slope is 0. That marginal change where it's 0 is where it's maximized. That's the beauty of calculus, is that we can find that point. At that point, that instant point, at that instant point is where we maximize. So that's why we set it equal to 0. That's the maximum revenue point. And since our cost is 0, this is also our revenue function. Here is our cost function. I'm sorry, it is our profit function. It's our profit function. So the revenue here is our profit function because we don't have any marginal cost. There's no marginal cost, so we're not concerned with marginal cost. So now we have our profit function. And we maximize profit because that's what we do. So, okay, now, and you pointed out, it's 50. So the marginal cost and that it maximizes at 50, but what's our marginal cost function? It's this. That's marginal cost. That is marginal cost. I'm sorry, marginal revenue. Well, I'm sorry, marginal revenue. That's our marginal revenue. Okay? See that? Make sure we're okay. Okay. Okay, now, and now, so we have our revenue. Then you can draw, using that equation, then you can draw this. And it looks like that. So it's going to cross right there. That's why I told you to wait, because you need to get that. You just started to draw that, but you don't tell me, you got to tell me where that comes from.
Yeah.
It doesn't just come out of air.
It just makes sense. Okay.
That's why we're going through this, to make sure we compute it. We want you to not just to say, oh, okay, well, I just draw this line. I want you to be able to know where it comes from. It's not magic. It comes from something. And when you can do this, now you understand it. Now you'll understand it. Okay? So we've done it. And you can sit down. Thank you. Very good. Okay?
Yeah, we were writing marginal revenue at the beginning, but actually.
That's why we want to go to carefully derive all of this, so that you can see. Because when you can see all of this process, then the model starts making sense. And I just wanted to go over, because this is a short run model. And the reason why I'm asking you to sit, because we don't have time I want to get through all of these. Your let's see, the, hold on, our marginal, there's one other point, I'll think about it in just a second. Marginal revenue. Marginal cost equals marginal revenue. Oh, the fixed cost, of course, the fixed cost. We have a fixed cost. We didn't say what the fixed cost is.
Right.
Because that's our that's ultimately our profit is actually the revenue minus fixed cost. Remember that, keep that in mind. That's what we're talking about here because it's a short-term model. This is a short-term model. So we have to look at revenue minus fixed cost. And remember we had the problem to say, well, what's the level where you can enter the market? In here, you can't enter the market. If Q is 50, P is 50, you can calculate. If Q is 50, P is 50, that means you maximize the revenue at Q times P equals 2,500. So then, if your fixed cost has to be less, than or equal to 2,500.
Yeah, right.
That's it.
If over, then.
And we had that problem. You had that. I asked you that question. Your revenue has to be, your fixed cost has to be less than or equal. Could be equal. That would do zero profit. That's the firm would operate. It would choose to enter the market and operate in the long run. It'll operate in the long run. Into that. But this is a short run model. But so this shows us why we end up. We end up like this. This is why. So we end up. This is the conditions that we end up with a long run monopoly, is because we're looking at this situation in the short term. And that game that I showed you, that was a short term game. That's in the short term. They're doing this. They're playing that game. They're competing. That competition is taking place in the short term. And under those conditions, the firm one wins and does this, and this is what they do. So that's the outcome, and that's why again. Then you might take. That's why you have regulation. It might not be socially optimal, but that's another story. We're not there yet. We're starting to talk about government, the role of government, but right now this is what happens. Okay. Next, we're going to talk about monopolistic competition, and I want you to come up and talk about that.
Can I ask one question?
Well, you can ask as many questions as you want.
Yeah, this model.
That's
model.
yes.
And should we write a fixed cost as like the assumption?
You mean the cost curve?
Fixed cost, yeah.
It'll result in a cost curve. You'll get a cost curve out of that per the quantity.
Yeah.
And
then that's it.
Yes.
Oh, right. Okay.
Yeah. That'll have a total cost. That's your total cost. Your average total cost would be that curve. That's your average total cost. It's based on the fixed cost.
Oh, right.
That's because that comes out of that. That's where that curve comes out of. That average total cost curve comes from the fixed cost. Okay? Now we'll need to move on. We can talk more about that, and that's a good question. And go back and when you watch the video, remember, reinforce that in your mind. Now we're going to talk about competitive monopoly. And a competitive monopoly, and
That's the one that's trouble.
yeah, and that's why I've asked you to come up.
Yeah, very.
Monopolistic competition. I want you to. You're struggling with this, so I want you to deal with it. Okay. Now, so the monopolistic competition. Are we talking about? We could be talking short term or long term.
Long term.
I think it's long term.
Yeah.
I mean, we can have a short term gain, but the outcome is some long term.
Zero economic.
Not necessarily zero. It could be. It could be. But the important point, your point, it could be zero. In other words, if you have many firms, and in each subsector,
Yeah.
then it would be zero. But you may have positive profit. And for example, in the spatial competition, you can have a positive profit. And that's a monopolistic competition outcome. So you can have that, but if there is, and if you have many firms in each subsector, then it is zero profit. So it is basically there's a short-term game, but it's a long-term outcome. So let's look, and what I want you to do, remember what I said last time about the segment?
Yeah.
So put them on the board, and give me, let me just write this down. Get going. Because we gotta keep time. Okay, show me a,
Different color, I need to use.
that's, yes.
Yeah.
So give me an overall demand curve for, we could have handbags, we could have shoes, we could have diamonds, whatever. You kind of think of a market that's has segments, where you can have segments. So just write out an overall demand function.
At first.
Yes.
Okay.
So you want first use the white. It's an overall demand function. Okay. Okay, so that's an overall, and why don't you put some numbers on there just so that we
Okay.
don't put 100 because we already used
Yeah.
100. There's a lot of other numbers that can be used.
300.
Okay, and the quantity? 300. Okay, that's fine. That's fine. You could use any other number, but that's fine. Okay, so price quantity, very good. Okay. Now, and what you write out the equation. So what equation is that? Price.
Should I write X? No.
That doesn't. It doesn't matter. Very good. That's exactly right. Okay. So that is the demand function for this. That's the total market. What product is this? We're handbags. Don't use handbags.
Okay, brand coat.
A coat. Okay, coat. Good.
Okay.
That's good. Coats. And you could have like a coat, any kind of, to coat that homeless people wear, to the coat that that rock stars
From
wear.
expensive to less.
Yeah, the most expensive to less. Okay, so coat. A coat market. Okay. So all right. So now put segments
Okay.
to that. Now in a coat market, there's segments. Very expensive coats. You could have cashmere fur coats, cashmere coats, down to the cheapest coat. A cheap coat might be just Now what he's doing, he's making. This is one way to do it. This is one way to think of it. There's other ways to think about it, but I just want you to think about it this way, that we're looking at segments of the market. Okay, that we're making a segment. These are expensive coats. These might be cashmere coats, and these might be your seasonal summer jacket, very light jacket. It's very, very cheap, and that you'll only wear for one season. Say something like that. Okay. So you have these various segments of the market. They're all coats. You can all put them on. You can take them and put them on. And they all do that, but they're different. They cost different. They do different things. So firms can specialize. So firms can differentiate. I can have a coat. Maybe my company makes coats that just do for winter coats, or for raincoats, or for fashion coats. So whatever kind of coat. So now we're going to. So we've got that total demand curve. Now let's focus just on a segment. And what we'll do. So we've got long term. Does the firm have market power? Do firms in this market have market power?
I think yes.
Okay, why?
Because each segment, the firm dominating the segment
Yes.
of the market, so they can decide their price.
However small the segment gets, there's some area. So if we chop it up smaller and smaller and smaller, it's still some area that the firm is dominant.
Yeah.
But the firm is competing. Every firm is competing with with other segments.
Yeah, each segment.
Each segment, they're competing with all the other segments. So that if the cashmere coats get too expensive, well then maybe people will buy this. So, you know, there's,
Differentiate.
yes, so that's, so you can differentiate, make differences, and no matter how small you get, that ultimately this firm still has a what slope? What is the shape?
Downward slope.
Downward
demand
slope,
curve.
demand curve. It still has a downward sloping demand curve. That's the difference between that and perfect competition. This is monopolistic competition. Okay, so what we're going to do here is we're going to assume that there's only one firm in a segment. So take a segment and tell me how, let's take that segment and just put some prices there.
To make this more simple, yeah,
Okay,
100,
okay,
and then, yeah, 50.
okay, and here, 50, 100?
Yeah,
Is that- Okay, 50, 100.
And
Okay, now draw, so now what you want now is
pick
draw,
one segment.
well now you've got this segment, so draw that again. So now he's going to draw that again, he's going to draw this segment. Now just make that to where it's just that segment. And this is the 0 point, that's the 0 point. So now this is the overall demand curve. That's the overall demand curve. Now this firm, now we're going to say this firm is a monopoly here. They're a monopoly there. That's why it's competitive. They can compete on the segments, but we get in their own segment and they have a monopoly. They have a monopoly in that segment. The convenience store has a monopoly for the households and people in the surrounding area. They have a monopoly. The coat maker that makes a specific coat has a monopoly in that area. But it substitutes. I can go to a different convenience store down the street. I can get a different coat. I can get a falafel, or I can go get yakitori. In your situation, what Eddie was dealing with at the Monster
Festival.
Right. So that's the kind of competition we're talking about. Now, so you got that. Now,
Yeah.
it's now put it the equation, new equation.
Yeah. Price equal 250 minus.
Q. Yeah. No.
Yeah.
No. Okay. Right. It's 250 minus Q, but it's
Should
in.
I put A?
It should start from 200, right?
Sorry.
Well, I mean the price should start from 200.
Right. That's right. Right. Good. Good point.
Okay.
Right. Good point.
Yeah.
Okay. And then in that range, and
But it doesn't
and
make
P is the range. It's the range of 200.
250, yeah.
Okay. Right. Okay. Now, calculate the and so
This doesn't make sense, isn't it?
what's that?
Because if put Q into 50, the figure 50, then the price would be 200, right?
Well, this is where they're operating as.
Okay, never mind.
That's where they're at.
I confused, okay.
Okay.
I understood.
Okay. Now, how about marginal cost? What kind of marginal? Now we could have.
Yeah, we could have, but
Do we need to have any marginal, specific marginal cost here?
I don't think
Make it as
that
simple as
is the
possible.
assumption.
Make it as simple as possible. What kind of marginal cost would you have? That makes it as, what is the simplest marginal cost that would satisfy, that works with this model? What kind of marginal cost would you do?
Zero
And that-
marginal cost.
Yeah.
Zero.
Okay, 0. That's
Oh,
fine.
all right.
Okay, then go through, now what's the cost function? Write down the cost function, just like before, just like you had it. No, the cost function, that's not.
Oh, right, no.
No, the cost function. A times QA. Right, okay, sure. That, you don't have to go through it.
Okay.
Right. Okay, just to see that, he's written down the same cost function. So the marginal cost is some A, we can make A 0. So you've already calculated that, you don't have to, but,
Cost
right,
function.
yes, yes. Okay, so now calculate your marginal revenue.
Marginal revenue.
Yeah.
All right. Should I writing from revenue function?
Correct.
Okay.
Get me a revenue function.
Can I erase this?
Absolutely, because you don't have to worry about that, we make it simple. Now you can see why we simplified, because it doesn't, when it doesn't matter, you don't use it. Because it doesn't tell us anything more really.
Okay. Just like he did, 200 minus.
Okay. Right, but you've got, and now I'm trying to think, how do you, because I'm thinking, you've got to do it in this, it's limited in this range. It's limited in that range. You can't go outside of you can't go outside of that. How do you write that? Thinking about that,
Just
because it's not 125.
refer to the graph. Is that the left side of the graph or the right side of the
What do you mean?
graph? We can just calculate the point of which is the instant derivative is 0, and to judge the 200 in
that range.
25 is the left side of the graph
Right,
or the
right,
right side of the
right,
graph,
right.
and decide on that.
Right. Okay. So calculate that.
Then, if I derive the calculus of this 200 minus 2q, but it doesn't make sense, right?
Yeah, this is the mark. So
Now, how much signal?
so you want to calculate a marginal revenue curve.
Yeah.
So calculate a marginal revenue curve with that. Because our optimal is not 125. So calculate the margin. You see where this is going? Yeah, thanks. That's you've pointed that. Right. Thanks for pointing that out. Because it's one of the same standing up. Let's see. Okay, where do we go with this?
5.
Right. That's fine. Right. No, don't worry about maximizing. Don't worry about maximizing. We just have our revenue curve. Our revenue curve.
Yeah.
So our revenue then is equal to 250 minus
2qx.
2qx. Yeah, that's right. Okay. And let's see, our 200 and p is greater than or equal to p is greater than or equal to 200. P is greater than or equal to 200 and less than or equal to 250. That's in that range. So that's the range that P can be. So in that range, you want to now calculate the maximum. In that range is where the maximum is.
That's right. Prices.
Well, since our marginal cost is 0, if it's this, it's just 200. Let's see.
Well.
And Q can be no more than 50, so it's no more than
No more than.
no more than 50. P when P is 200. Let's see. Calculate.
P is 200.
Let's see. No. Think about this.
The Q can only be 200.
Q would be 25. So what we're going here is that Q is.
No.
Yeah, 25. Q is gonna.
It's some kind of
225.
225.
And 25, but
Two-
this function
225.
doesn't.
I think
Makes
that's
sense.
the maximum. Oh, wait a minute, hold it.
100.
No, it's 50. Is that two? Let's see, that's 10,000. 10,000, you're right. No, it would be. It would be the maximum output. You're right, that is the maximum.
The maximum is 100, right?
No.
Well, no, because the maximum's 50.
Yeah.
It's 0 to 50. This is the maximum. This is the maximum is 50. That's the most you can. That's the most you can produce. It's above The maximum would be 125 if it had the whole demand curve, but it doesn't. So the maximum output is 50 and your revenue is 10,000. So that's your maximum. Okay. It's a little bit more complicated, isn't it?
Yeah.
Yeah, and I'm trying to do it too, because I'm trying to explain it. And as I say, what's interesting is that I'm trying to go through this to make this clear, but let's just keep that, and part of that is, I just want to see this process. I want you to understand, I'm not going to ask you to do this. This is more complicated, because you're going to be pulling your hair out. Just remember, it's this that you're talking about, the segment. I want to ask you a complicated question about this. What I want you to understand is that it's a segmented market, and within the segment, whatever the segment is, there's the firm has market power and can act as a monopolist within that segment. And so this is kind of how we do it. This is kind of the way we model it. So, okay, great. Please sit down. Thank you.
This function
Well, that's okay.
Oh,
Yeah, don't worry about that.
Thank
I want to just go through this. See, it's a little bit complicated.
Yeah.
We're trying to work this out, but you can see, and part of this we're seeing,
the idea.
it's too complicated. I can now see it's too complicated, so I want to ask you this.
Oh,
I want to
alright.
ask you that.
Thank you.
So I'm seeing that, and so I want to ask you to do this. Okay.
All right.
So thank you.
Thank you.
That's what I'm doing here, is trying to keep it simple. It's a little bit more complicated, so we'll just keep it simple and not make it too complicated. Okay. Okay. Now the next thing we're going to do is monopoly. And Eddie, I want you to come up and talk about monopoly. Now, and let's get, you can use your own numbers, different ones than what we've used so far. We have P and Q. Okay, now the first thing is, okay, monopoly, are we talking about short-term or long-term monopoly? Remember we talked about natural monopoly short-term. Is a monopoly short-term or long-term? Why both?
I'm not clear about
Okay, let's try to think. That's why you're here. That's why you're up here. We're trying to think to get it clear. Now the short term, we're talking about. Remember the short. What did we? Why was it in the short term for a natural monopoly? It was in the natural monopoly in the short term because there's a competition. And one firm wins out. It's a natural monopoly, so we have to look at short term. We have a fixed cost. Do we have a fixed cost here? So if there's no fixed cost, then is this short term? No. So if it's not short term, what is it? So it's long term. Now can we repeat all that? Do that again. Is this short term or long term?
This is the long term.
So why is it long term?
It's because there is no fixed cost as a natural monopoly.
And what is a fixed cost? Fixed cost matters when? What fixed cost matters in which short run and long run?
Short run.
Correct. So the long run, are there any fixed costs? Or are there fixed costs in the long run?
No.
Okay, so all costs are variable. So in the long run, all costs are
variable.
they're very.
In the longer term,
Yes.
the cost in monopoly, the cost has only one firm, so
Correct. Yes.
there is no fixed cost.
That's correct. So it doesn't matter. That's right. So in the long term, all costs are variable. All costs are variable in the long run. So that's it, the long term, where all costs are variable. Okay, now, so now tell me a model. So what, does the monopoly, the firm with the monopoly have market power? So what does that mean? So what is the demand curve that the monopolist, the firm, the monopoly faces? Downward sloping. Okay, now, so to draw me a downward sloping demand curve.
They have numerical.
Okay, got some straight, okay, now put some numbers on there. What's the price?
1,000.
Okay, 1,000, okay, good. Put any number you want. You can put 1,000, okay. Now write an equation for that demand curve. Okay, that's great, correct. Okay, so what does this tell us? What does this equation tell us? What is the relationship that this...
The relationship between the price and quantity.
Correct. It's the relationship between the price and the quantity. We're fine with time. Okay, good. It's the relationship between price and quantity. That's the demand curve. That's why we have the price and the quantity. When we have that, that's a demand curve. Okay? Now, so do we have what kind of cost curve? Now write me a cost curve. Now what kind of cost curve, and write one that, what kind of cost curve do we need to talk about this, the firm that is a monopolist?
The shape.
Correct. What kind of shape? What kind of shape? Draw me some cost curve. Any kind of cost curve you like. Okay, why are you choosing that one? There's nothing wrong with that. There's nothing wrong with that.
Average total cost.
Sorry?
It's just like, yeah, average total cost, different function. That's it.
Because we're, this is long run. It's long, I'm sorry, I got a term, because long run. So long run, okay, that's okay. So write an equation for that. Write some equation for your cost curve. So write a cost. So the cost curve. Our cost function? What I'm asking you to do is to write a cost function. Our cost function tells us the relationship between quantity and total cost. So A times some QX. Okay, that's a cost function. Very good. A simple cost function. Now, what cost function? What value for let's say for both A and Q do we need for this model? What type of to understand the choice of the monopolist? The monopolist has market power. They have a downward sloping demand curve. We want to understand the choice that the firm makes, the monopolist makes. So how important to the choice, which is the most important? This, the demand curve or the cost curve? Which is, are they both important? Do we need, which one do we absolutely need? We need absolutely, why this? What do we need this for? What is the demand, what do we need the demand function for?
Because I can't calculate the cost curve because this is it lacks of the another.
You're getting ahead of it. You're getting ahead. Step back, because I've seen what you do. You start thinking. You start kind of going all over the place. I've seen you do this. Okay. Stay focused. What does this? What do we use this for? This is what do we need what are we trying, we're trying to maximize what? Trying to maximize profit. So what's the most important part? Write down the profit function. Write down your profit function. That's not marginal revenue. You're writing a marginal. No. That's your equilibrium. Okay. Okay. Do you see what I'm trying to get you to do? You get ahead of yourself. Do you see what you do? You get step back. Don't jump. Write down what's the revenue. Write down the simplest revenue function. Revenue equals, what's revenue? Okay, times exactly. Do you see what I'm trying to get you to do? Do you see why you're struggling with these problems? Do you understand? Do you understand? You tend to jump ahead. Okay, you understand this material, but you jump ahead. Remember what I told you to write down your definitions? When you get confused, write down your definition. I've asked you to say what matters. What matters? Here's the price, the quantity, and the cost. What matters? We want to maximize profit. So we maximize profit. What's our profit function? Write down profit. What's your profit function? Write down a simple profit function. Write down the definition of profit. Profit equals. Okay. Equals. Okay, what is it? That's it. Exactly. Okay? That's it. Okay. Now, step back, literally. Look at this. You see, your profit, the firm wants to do what? It wants to maximize what? It wants to maximize the profit. So look at this function. The revenue and the cost. Does the cost matter? Which one matters the most, the revenue or the cost here for the monopolist? The cost? So you want to maximize cost? Minimize cost? Well, you want to minimize cost, but how do you, when you minimize cost, then what?
Then the profit is maximized.
Yeah, but you don't know what the revenue is. How do I know the revenue? I don't know the revenue yet. You're focused on the cost. So which one do we really care about? If you have to, which one is most important here? You want to maximize profit. You have revenue minus cost. What I'm saying is, what happens if cost is zero? Does cost need to be positive? Does it need to be positive? Why?
No.
No. Okay, no. Okay? So let's forget about it. Right now, let's forget it. We could put it in. We don't have to worry about it. You see that? It's revenue. We care about revenue. Okay? Okay. Now we have this demand function. We want to get revenue. How does the firm now show me? I'm going to erase all of this because all we care about now is the cost function. This is the demand curve. That's the demand. Now show me the revenue. How do I get revenue? Now write down the definition of revenue again. Write down the definition of revenue. Revenue equals price times, very good. Okay, that's the definition of revenue. So the revenue is what I get for each unit, the falafel, 450 yen for falafel times the quantity that I sold. That's your revenue. Okay, that's your revenue. What's this? Correct. So and so then, now write your revenue function in terms of the demand function. Okay, let's stop. Do you see where we're going here? And what I'm telling you is that I see the way that I'm looking the way when you do your work, you start jumping ahead, you're kind of jumping, your mind is kind of going all over the place. Stay focused. Think about the definitions. I've asked you to remember what I told you. I said to write down the definition, okay? So, and when you did that here, did that help? The definition, when you get these problems, don't start running around and start writing stuff down. Remember your definitions and what your objective is, what the firm is trying to do, what the objective is. Okay. Because I know you can do these problems, but you got to stay focused in order to do it. Now, so that's the revenue. Now we want to maximize our profit. So if our cost is zero, what do we maximize if all we have is revenue? How do we maximize our profit? Don't write yet, just think.
To maximize revenue.
Exactly. We want to maximize revenue. So we need to determine what the marginal revenue. Okay. So first we do that. Now show me just the idea that we're trying to do here. Just draw me a marginal revenue curve. Okay, that's some marginal revenue curve, right? Okay. Yeah, that's fine. We don't have to, we're going to calculate that. That's what we're going to calculate. You're getting ahead with that, but I want you to see, and so if our marginal cost is zero, that's because it does, if it's here, if it's this, it doesn't matter. None of those matter. That's just going to change the intersection, but it doesn't change what we do. What we ultimately do is we're concerned with the revenue. Okay? Okay, you're doing fine now. All right? Do you understand what we're doing here? If we started all over again, could you do this again?
What I have to do is marginal revenue.
Correct. Okay, so show me the marginal revenue. So you've calculated, okay, you're absolutely correct. So did you do that in your head? That's very, you understand calculus. You can do this stuff. See, the thing is, you have no problem with this. You just have to keep all this correct in your mind, and to keep your mind clear and focused and disciplined. And when you do that, you'll be able to get all these problems. These problems will become very easy. Okay? Okay, now tell me the maximum. So marginal revenue equals that.
Marginal revenue equals, it should be zero.
So that is your maximum. So you maximize that when that function is zero, right? Okay. That's where the 500 comes from. That's exactly where the 500 comes from. Okay. And that's it. And that choice at 500, so our quantity is 500, what's the price? What's the price?
500.
No. 500, because QX is 500, that maximizes, so you put that in, 1,000 minus 500 is 500. Very good. Okay. Right. Excellent. Okay. keep that in mind. When you do these problems, don't jump ahead. Step back. Always tell yourself, step back. Make sure you write down your definitions, what you're trying to do, and then you can see what you have to do. Because you can do these problems. You can do these problems. Just get that discipline and you're going to start being a much better student. Okay? Okay, thank you. Okay, now, okay. Now it's your turn. So Taiga, please come up. And you're going to talk about perfect competition. You're going to tell me about perfect competition. And we're going to write that down. Because I know you've struggled with these problems. Have you learned, what have you learned so far today? Does this help?
Yes.
You feeling more comfortable about understanding this?
Yes.
Okay, now I think you don't know calculus, is that right? You have not studied calculus?
I studied calculus, but I can't calculus these calculus.
Okay, do you understand?
Yeah.
Okay, we'll see. Okay. Perfect. Competition. Okay. Now, okay. Now, in perfect competition, are we talking about short term, or short run, or long run?
Long run.
It's the long run. We're interested in the long run. So we may talk about, now we have models, and we talk about the firm in the short run. We can see choices in the short run. But we're going to look at the long run and the choice that the firm makes in the long run. Okay. Okay. So that's a typical long run. So long run, are there fixed costs in the long run? Do we have what is the fixed cost in the long run? What is there a fixed cost in the long run?
There's no fixed cost
Correct.
in long run.
That's correct. There's no fixed cost in the long run, so we don't worry about fixed costs. Okay, so now draw me a market demand function in a perfect competition market for the whole market. The whole market. Draw me a demand function for the whole market. Okay, correct. The whole market, the demand is downward sloping. Now put some numbers as the other students have done. Okay, 200, that's good. 200, fair enough, that's fine. And now write me a demand function. Write me a demand function for that, write out the equation for that demand function. Correct. That's the equation for the demand function. But now there's something that's different about perfect competition. Do the firms in perfect competition have market power? Do they have market power? Why? Each firm, how many firms are there in perfect competition?
Many.
There are many firms.
Firms.
Okay, so write down many. There are many. Write that down. That there are many firms. How much is many? Write down a number for many. Write down a number that you think.
Funds, the number of funds.
Yes. When you see many, what do we mean by many?
Many.
Yes.
50.
Could be 50, probably more.
100.
1,000, 100, 1,000, 10,000, a million, a billion, a trillion, many, lots, many, 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 many. That's what we mean by many. We don't mean 50, we don't mean 100, we mean many, 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 many. Snowflakes, many. That's what we mean. That's what it means. And each firm is very small. So do the firms have market power? What is market power? Now this is the industry demand curve. This is the industry. That's all firms. Show me the demand curve now. If one of the firms, one of the many, 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 many firms, what is their demand curve? Write down some demand curve.
Many.
Yes. Which is their, and remember that in here the demand curve, it's their marginal revenue curve. Write down the demand curve. Write down a demand curve for the firm in perfect competition. One of the many firms. One firm. Write down for one firm. Write down what is the demand curve
One firm.
for one firm. Just draw it on the graph. Draw what you think the demand curve is. Okay, the definition of perfect competition. The firm does not have market power. It does not have market power. That's what perfect competition is. Go back and check very carefully. The firm does not have market power. So what does that, if the firm does not have market power, can it control the price of its output?
Consumer.
Not the consumer, the firm.
And
Can the firm, what is the relationship between the price of the product and the output? That is the demand curve. The demand curve is the relationship. When you go back, make sure you write this down. The relationship between price and quantity. That's the relationship. We've seen other demand curves. The relationship between price and quantity. The firm does not have market power. What does that mean? What is it that they can't control? They are, what does that mean to be a price taker? They are price takers.
No.
Okay, that's not. They can't control it. So what is the price? So write down the relationship between price and between price and quantity.
And the perfect competition.
Correct. Write down some relationship between price and quantity. Or actually draw it first.
This is not same one.
Okay, draw that. Draw the same one. Now, in this here, the firm if a firm has a downward sloping demand curve, that means that then I have a marginal revenue curve that looks like this. That's my marginal revenue. If I have that, then I can control my price. But if I'm a price taker, I can't control the price. I don't have any control over my price. I can't control my price. If that means that I don't have a downward sloping demand curve. It's not downward sloping. Okay. It's not downward sloping.
Okay.
Okay. Now, if it's not downward sloping, show me a demand, draw me a demand curve where the firm has no market power, it has no market power, and it is a price taker. That means they take the price. They can't change the price. They cannot, write me a function where they cannot change the price.
Right.
Yes. Where the price does not, keep on drawing, keep on drawing. You're doing fine. Don't stop, don't stop. You're doing great. You're doing great. Okay, good. That's a price. Let's say that's 100. That's price. The firm can't. So if the firm produces 1 unit of the good, what's the price?
Doesn't change.
2 units of the good.
Doesn't change.
3 units of the good.
Doesn't change.
100 units of the good.
Doesn't change.
Doesn't change. Doesn't change. Okay. Now, write an equation. Write an equation that shows the relationship between price and quantity, where the price does not change. So price equals. Yeah, that's okay. Now, very good. So, but you also have the quantity. Okay. So now write me where the P equals 100. That's correct. There's one more thing that he needs to put in, that you need to put in, and it's for the quantity, for any quantity. So put a value. Put Q. So Q QX. Now, if it's 1, then that means that as QX increases, the price increases. So what value do we put here to where for any Q that P equals 100? What's the value here?
2.
That's right. That's correct. Wait a minute. Okay. So now that's your that's your demand curve. This is the demand curve in perfect competition. This is an example of the demand curve in perfect competition, right there. It's the QX is 0. It's 0. You see that? Okay, now tell me the marginal. Now, now, so that's price times. Let's see, price times quantity. Right. So now put our you calculate marginal revenue.
Okay.
So what is the revenue? What's revenue equals?
Equals P times Q.
Okay, now do that. So now calculate revenue. Revenue equals, that's P. Okay. No, QX to the 0. No, you're doing fine. That's fine. Price times that. This is price.
This.
That's fine. Keep on going. You're doing fine. Right there. You're doing okay. No, it's not 0. 100. It's 100 times 0. It's not. It's 0. Revenue equals price times quantity. That's price equals 100 times. That's the price, QX, okay, times, very good, okay. This is to the 0. So let's see, just make sure I'm doing this right. 100 QX times QX. Is that right? No, something's not right there. Oh, that's just one. Right, that's just one. So that's it. Yeah, right. It's 100. Right, that's just one. QX to the 0 is 1. Right. QX to the 0 is 1. So now revenue. Now, so calculate that. Right. 100 QX. Now, so okay, now that's our revenue. 100 QX. Now, what's the derivative of 100 QX?
Derivative.
How does the revenue change with the change of QX? Okay. If QX, what is the, if QX is 1, what's the revenue?
100.
If QX is 2, what's the revenue?
200.
How much is it increased?
100.
If QX is 3, what's the revenue?
300.
How much is it increased?
100.
QX is 4, what's the revenue? QX is 4, what's the revenue? You don't find. QX is 3.
Equal.
Okay, QX is 3, the revenue is what?
300.
Okay, QX is 4, what's the revenue?
400.
And how much has it increased? It always increases by 100. So it always increases by 100, so the marginal revenue equals to 100. Okay. So that's this line.
Oh.
That's how we got that line. That's where it comes from. Okay. 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 What I'd like, what I would, let me just go just very quickly, because unfortunately we ran out of time. I want to spend a little bit more time with you. If you can you have a few minutes?
Yes.
Okay, I want you to stay if you can. Now you're welcome to stay or you can leave. I'm going to keep on filming this, so if you need to go, please feel free. I do want you to stay for just a little bit longer, because I want to make sure that you understand this. Okay, now draw me what kind of cost function. Now, we've had these other models. The cost function hasn't mattered.
Cost function.
Yes.
Cost function.
Write some cost function. Draw here. Draw a function. Yes. What is the cost? Is the supply. The marginal cost equals the supply. And that's fine. You can go. I'm going to have this. Thank you very much. And I'm going to send you. Thanks, Eddie, for. I'll send out the
Extra credit.
the extra credit. I'll send that out, and you will get that. I'm planning to do that on Sunday. Is that going to be a problem? Do people have tests next week? Is there any problem? You're okay?
I have 合宿ってなってるんだけど、映画。
合宿?
Excursion. She's gonna go to like remote place.
When are you leaving?
アイセックの合宿で、
This
終
excursion.
日パソコン開けないんですよ。
She has no Wi-Fi connection.
Okay.
Can't browse.
When are you coming back?
Sunday evening.
Oh, that's fine. You're fine.
あ、何？テストいつ出るだっ
It's
け？マンデー、
日曜日.
日曜日のmidnight.
So
Wednesday.
Wednesday. So you're
Wednesday.
fine. You'll be okay.
You'll be okay.
Okay. That's fine. That's fine. Good. Okay. Great. Well, that's great. Well, finally, that's fine. Okay. Great. Okay. Now, let's get back, so your marginal revenue, let's have now let's put a marginal cost. So your supply, your yeah, let's put your marginal cost. Let's see. If the output, what kind of marginal cost curve do we? Sky Muscat? Okay, we're done. Okay, we need to stop. See, Mr. Shoshin. We'll need to quit. Okay.